very typical real life kind of question. We have laws on the books that say that a work week is 40 hours long. And if you work more than 40 hours in a week, these are for hourly paid positions. First off, let me backtrack even further. There are two types of jobs. There are hourly position jobs and there are salaried jobs. I get paid a salary. I get paid a certain amount of money for the year. That's it. It doesn't matter how many hours I work. So, theoretically, I could come in the very minute my school day starts and leave the very minute my school day ends and never do any other work and get paid the same exact amount that a teacher that comes in a half an hour early and leaves a half an hour late and does lots of work at home. Because it's a salaried position. It doesn't matter how many hours you put in. But that's not the way most jobs work. The only way you get to that level of pay is if you get what they would consider to be, for the most part, a kind of a professional job. Okay. Now, another example would be professional athletes, right? They sign a contract and they get, so-and-so makes $1 million a year, so-and-so makes $500,000 a year, or an actor or actress in a movie. Jennifer Lawrence in Hunger Games, she might have made $25 million for the movie. That's just the fee for the movie. It doesn't matter how many hours she worked. But that's not the way the real world works for most people. For most people, you work on a 40-hour work week. So, for example, if you got paid $10 an hour, the first 40 hours, you would make $400 an hour. Or $400 a week, I'm sorry. Now, what happens if they want you to work more than 40 hours? Well, many, many, many years ago, before they made this law, they would tell people they wanted them working 50, 60, 70, even 80 hours in a week. And they would just keep paying them $10 an hour. But the way the laws read now, once you get past $40 hours in a week, you now have to get paid time and a half. Which means instead of making $10 an hour, for everything past 40, you get paid $15 an hour. Half again more. So half of 10 is 5, 10 and 5 is 15, you make $15 an hour. If you made $20 an hour for the first 40 hours, then for the next one, you would make $30 an hour, okay? That's a very typical, that's the way life works. Growing up, my dad was a railroad conductor, and he used to try to get all the overtime hours that he could possibly get, because that was the extra money that the family needed if they were going to do anything that needed to be done. The other thing is, sometimes on holidays, you can get double or even double and a half time. Now, this graph is a picture of what it's like to be paid. And when you look first at this graph, you might say to yourself, it almost looks like it might be kind of exponential. Well, it's not a straight line. Can everybody see the bend in there? So then you might think it's kind of exponential because it's starting to curve there. But then two things say that there is no way that this could be an exponential graph. The first thing that says there's no way that this could be an exponential graph is because it goes through the point 0, 0. And if I put 0 in the variable place, what is anything to the 0 power? 1. So therefore, it should go through the point 0, 1 if it was exponential. It's obviously not exponential. So what this is, it doesn't look like a regular straight line either because there's a bend in it. This is a piecewise linear graph, which we did a lot of earlier in the year. Remember the problems with the snow, remember the problems with the time flies and the Rangers crushing the Islanders. All of those very fun, very real life questions that were done earlier in the year. Well, if you read the context, when it talks about time and a half, up until 40 hours, which is right here, the rate of change is one thing. And then past 40 hours, the rate of change, or slope, changes. Okay? And those are the two graphs put together to make what if you worked 70 hours in a week? Well, part of your pay would be where I just had it in red, and part of it would be in the blue. So let's write an equation that takes care of your pay until we hit 40 hours. So from 0 hours worked to 40 hours worked. And since this is a piecewise linear function, it's going to be in the form y equals mx plus b. And the y-intercept is 0, so that's nice. So I get y equals, and now I have to do slope. Slope is change in y over change in x. So does that say 198 or 188 on your paper? 198. Okay, so I got 198 minus 0, which is 198, over 22 minus 0, which is 22. And I believe that goes in there 9 times, right? 180, yep, perfect. So it's y equals 9x plus 0, which is just y equals 9x. Okay? Now let's take a look at the other side. Now, the first thing I want you to notice is this is only true when it gets past 40. Okay? I don't know what the y-intercept is. Is it pretty obvious that if I continued this line, the y-intercept is lower? Okay. So let's go to figure out what this slope is and so on and so forth. Y equals mx plus b. Y equals, now the slope is going to be 765 minus 630, which is 135, over 70 minus 60 is 10, which is 13.5. So y equals 13.5x plus b. Now there's a couple of different ways to figure out what b would have to be. One way, does it make sense that there's still 40 hours left to go until I get to the y-axis? Does everybody agree with that? You with me here, girls? Right? So, if I do 40 times 13.5, that would be 540. And then if I subtracted 540 from the value at 40, which is 360, if I do 360 minus 540, I come up with negative 180. So, I could come out with y equals 13.5x minus 180. Or, another way to do it is this, and I'll do it in green. I have y equals 13.5x plus b, and I can just plug in either coordinate. I'm going to plug in 60 comma 630. So 630 equals 13.5 times 60 plus b. 13.5 times 60 is going to be 780, 810. So I get 630 equals 810 minus b. And can you see when I subtract, oh, plus b. When I subtract 810 from both sides, I also get minus 180. So either way, it's going to work. Now, how does this relate to a function rule for this graph? Well, it's a piecewise linear function. First, it's if x is less than or equal to 40, then you're going to get the rule that says y equals 9x. And then, for x greater than 40, you're going to do y equals 13.5x minus 180. Okay? So these are the two different rules put together. And then if you want to actually write a single function rule for what you would come up with, you would say y equals 9x covers the first 40 hours, and then plus 13.5 times x minus 40 minus 180. Now, this covers your first 40 hours. Agree? Why did I take the 40 away in the parentheses from the x? Why do I take those 40 hours away? There's a very important reason for it. Come on, think. I know it's a Monday after you move the thing ahead. Go ahead. Right, we've already counted those 40 hours. This new rate of 13.5, listen, if you go work for your boss, and you work for your boss for 40 hours, and you get paid $10 an hour, you got your 400 bucks. But once you pass 40 hours, do you still get paid $10 an hour? No, what do you get paid? 15. But that 15 doesn't go back and apply to the first 40. That 40 was $10 an hour. It's only past 40. So when I write x minus 40 here, I'm figuring out how many hours are past 40. Those I'll multiply by 135. In fact, I don't need the minus 180 here. Get rid of that. So this is going to be, let's figure out 50 hours worth of work. If I work 50 hours, 9 times 50 is 450, plus 13.5 times 50 minus 40 is 10. That would be 450 plus 1350 times 10 is 135, which would become $585 worth of work. Now, let's go over to the graph. 50 here, and that should bring me up to, this is 600 here, 200, 400, 600. Right about 585. Okay? All right, so that's just a little real life example of how pay works. So much an hour for 40 hours, then time and a half after that, and you use the two slope formulas. Questions? All right. Now it's a little bit of a recognition game. Let's turn to here. And let me cut back in size to 100%. Okay, what's that parent function I graphed right there? What's the name of that function? It is linear, that's the type, I agree. What's the parent function? What's that? Yeah, y equals x. We simplify it as far as we can go. It's linear, it's y equals x. Okay? Why, how do you know that? Well, a couple of different things. It's a line, the y-intercept is 0, and the slope is up 1 over 1, up 1 over 1. Okay? And it's really a line that you should kind of have memorized. It's the perfect diagonal line going across. On your paper, very quickly, equals x plus 5. Good? Right? Y equals x plus 5. Now I want you to graph this one. Ready? Y equals, in parentheses, x plus 5. Actually, let's change that. Make it minus 5. Otherwise, you're going to land right on top of the other graph. Y equals x minus 5. And what kind of shift is it on this time? Horizontal shift, and I'm going to move right or left?
Right.
I'm going to move right 5 places. 1, 2, 3, 4, 5. There's my graph. Okay? Any questions? All right. What's this next parent function?
Absolute value.
That's very good. Y equals absolute value of x. How do you know it's an absolute value function? What shape is it? A V. Right? A U is a y equals x squared as your parent function. It's a parabola. If it's a perfect V, it's an absolute value. Okay, let's see you just very quickly on the same thing. Graph the following. Y equals negative absolute x plus 4 minus 2. So, like that, right? The negative flips it. Plus 4 moves it 4 to the left, because horizontal shift is reversed. Horizontal always being in the grouping symbol. And the minus 2 brings it down 2 on vertical shift. We good? Okay. What's the next one? It is definitely exponential. And honestly, I get a little confused. This graph is definitely y equals 2 to the x. And I guess they use that as a parent graph. Sometimes I think it ought to be y equals a to the x, but this is clearly y equals 2 to the x. The reason I know that is I looked at a couple of the points that it passes through, and it has to be the equation too. I want you to graph this. Ready? So it's vertical shift, we're gonna go up 5. 1, 2, 3, 4, 5. And every point should go up 5. 1, 2, 3, 4, 5. And then let's go with this one here. 1, 2, 3, 4. Now, the thing that's a little tricky about this, remember we talked about this word the other day, asymptote? And how it gets closer and closer and closer, but it never crosses that line. In this case, it would never cross the line y equals 0 for the parent function. And then, White Sox, get that door, please. For this one, it would never cross the line y equals 5. Work? Yeah. Good. Thanks. Did you put your address or our address?
19 Fairmont.
Okay. All right, so there's an exponential function, and we've done a vertical shift of 5. Take a look at the next one. What kind of parent function is that? Y equals x squared. Good. How do you know it's y equals x squared? Okay, good. What about the next graph after that? What's that the graph of? Y equals the square root of x. Good. Let's graph this very quickly. Bless you. Y equals square root of x minus 3 . Okay, what happens to the graph? Everybody?
Goes to the right.
Goes to the right 3. 1, 2, 3. Here's my graph. Okay. What about the next one? What's the parent function for the next graph? Y equals x cubed. Very good. And what about the graph after that? Cube root of x. Very good. It would be y equals cube root of x. So we're getting good at recognizing all the parent functions and applying vertical and horizontal shift to all of those functions. Any questions? Nicely done. Don't forget, work on those take-home quizzes. Get them a little done every day.